Hello, everybody. Welcome here to the Wine with Jimmy portal. Thank you so much for taking your time and clicking buy. So this is all about wine education, specifically aimed for those of you studying the world of wine and, of course, wanting to know more about a specific topic. Here I am launching my series on PIWIs. You'll see it written at the top. I'm going to go through exactly what that is. That's something which is certainly more and more important as climate change is getting its grip around the world. So please, if you do have a comment or a question, get in touch. Would like to hear from you. Please comment on this video below. Make sure you click like and subscribe, please. So let's start talking about PIWIs. It's a six-part series here. You'll see quite an important gentleman there on your slide. That's Alain Garbeneux, known very much for his work with the ResDur program within Alsace, France, and I'll go through that very shortly. So here you are about PIWIs, a six-part thriller. And this first video is available as free content, but part 2 onwards is only going to be available to those of you who subscribe to my e-learning platform. You'll see that at the bottom in green. That's over at www.winewithjimmy.com. Lots of really useful goodies there, training, resources, exclusive video content, maps, you name it, you'll get it. And the whole unit for PIWIs is available as £25 as a standalone series. So let's go through the definition of a PIWI. So terminology, of course, matters. Certainly, if you describe these vines as hybrids, people who may have some knowledge of hybrids within the world of wine may expect or fear errant flavours, like the classic sort of foxiness, they say. It's like a musty character in wine. And that's very much negative, which was really started in response to the early attempts of making wine in the phylloxera infested pandemic. So we're looking at the end of the 19th century. I'm going to go through this on some of the other slides, but of course the need to adapt the wine industry from then meant the creation of a lot of these new varieties, which we called hybrids, but they were not really accepted by the consumers of Victorian times, and that negativeness has certainly carried on to today. PIWI actually does stand, there's a link, of course, with hybrids, but it is a specific part, and they're very proud to call it PIWI rather than hybrids. So what does it stand for, PIWI? Well, the name stands for Pilze Widerstandsfähige, and you'll see it at the top there, Rebsorten. So that's the word, one of these wonderful phonetic long German words, which means fungant resisty. So fungant, what a brilliant word I just made up. Fungi resistant grape variety, or fungant grape variety. And they are specially bred fungus-resistant grape varieties with at least 85% vitis vinifera within their DNA. Okay, I'm going to go through the breeding process actually a little bit later on, so how we achieve this, but this is our definition for now. Pierre Basler, who was the founding member of the association called PIWI International, which was established in 1999, chose that following name, PIWI, when it was founded in the last month of 1999. In the first writings, he still writes about those interspecific grape varieties. And I think it was 2000 when it was officially first used as an abbreviation, PV, because utilizing Pilzwiderstandverhälter is a little bit more challenging. It doesn't roll off the tongue. So this was the first time we start to hear about it. So about 25 years or so of the name PV being out there, though the production of PVs does outdate that time. Why were we doing this? Why create PVs? Well, in viticulture, a considerable amount of pesticides or fungicides are being used to prevent possible fungal infestation in the vineyard level. And then we use all of these sprays to ensure a consistent yield, a consistent harvest. I'm going to go through in the next 3 slides the major threats of fungal infestation. But now, just for now, we're just talking about those threats and, of course, utilizing the breeding programs of PVs to reduce spraying in the vineyard. So that high tolerance which is being bred into these PVs mean there's a significant reduction in pesticides, herbicides, fungicides. Therefore, this is fantastic in terms of protection of the environment for less sprays. And with climate change, we know there comes significant localized weather pattern changes that are actively changing climates. Those weather patterns are changing the classic climates that we have in many key viticultural areas in the world. Some areas are becoming hotter and drier, and others are becoming warmer and wetter, a little bit like the United Kingdom, for example. And it's the latter there, that warmer and wetter, which is increasing humidity and therefore fungus and infestations. This is really where PVs will come into their own. So this is the impetus for breeding PVs that have fungus resistance. But also, in areas that are warmer and hotter, like the southwest of France, where Merlot is grown extensively, PVs and hybrids are now being more actively considered as Merlot is becoming unbalanced, often getting remarkably high levels of alcohol. And people are actually focusing on other varieties. So there's a bit of a movement away from Merlot and towards things like Manseng Noir, for example. So there is this desire in warmer places as well, really for achieving more balance. Now, let's understand those 3 types of fungal effects in the vineyard. The first one is called peronospora, otherwise more commonly known as downy mildew. So this is a water mold that lives within the vine tissue, not the surface. It's also known as Plasmopara viticola, and it's considered to be one of the most, if not the most, devastating disease of grapevines in climates with warm and humid, wet summers. It needs rainfall and warm temperature at about 20 degrees Celsius to spread. The high-risk periods are, of course, spring and summer, but certainly when there's storms within summer. And the symptoms you'll see on your slide, they are yellow circular oil spots, and then white downy fungal growth on the underside of the leaves. It also attacks the grapes, and you'll often see in a bunch of grapes affected by downy, you'll see lots of smaller grapes which are hard and dark green, and they have not formed successfully. So all of this reduces the yield, and the grapes that can be affected, of course, will be discarded, further reducing the yield. Another problem is powdery mildew. So this is also called oidium or oidium. This grapevine powdery mildew is caused by the fungus Uracifnecato, more commonly called oidium, as we mentioned earlier, or oidium tuckeri. The fungus is specific to grape vines, with American species being less vulnerable, less susceptible, so having better resistance. Now, this was introduced from America into Europe in the middle of the 19th century with the increased sort of movement of peoples, but certainly the movement of goods coming from the New World back into Europe. Now, powdery mildew overwinters in buds, and that's as mycelium, which is a mass of fungal hyphae ready to get out into the world, and also on canes as these little black spherical bodies. And then in spring, they release the spores from those buds that are opening up or from the canes, and these will germinate and restart the fungal disease. The growth rate is determined by temperature. The optimum temperatures for powdery are around 25 degrees Celsius, and it actually thrives in more shade, so it's better to have open canopies. So powdery mildew is known as a xerophytic plant pathogen, and that means it doesn't require the humidity, so it can actually spread in dry conditions, as mentioned, in dense, shady canopies. It attacks young green parts of the vine, which start off as these dull grey patches and become black patches as they advance. The patches can damage the shoots, the inflorescence, so your flowering, and grapes, reducing the yield. And the last one is, of course, Botrytis, bunch rot in all of its infamy there on your screen. This could always be called grey rot as well. So this is a fungus that causes significant damage to the fruit itself. So this reduces yield and a drop of quality in the wine. So typically reducing colour, body, and aroma and flavour. And of course, if this affects the grapes, it needs to be eliminated. Typically, producers will sort out the whole bunches if they are affected by Botrytis. The spores are typically present in the vineyard and become active in periods of rainfall and high humidity, typically towards the end of the growing season. So you're looking really at towards 20 degrees Celsius being optimum, moisture, which is free and easy in the air, and then humidity at 90-95%. The fungus overwinters in grapes, dead grape tissues, and other plant hosts. And in the spring, the fungus produces spores from hard resting structures. Now, these spores are dispersed by the wind, which will then cause several new infections. In late spring, it can infect shoots, blossoms, and leaves. And the berries that get infected, certainly in the early season, so this is early grape growing, will turn into sour rot. And when the infection occurs on berries after blossom, the fungus remains inactive until colour change. And then you'll start to see wounds on the berries. So the berries you've got fungus on it, you'll see in the picture here, causes a shriveling of the berries, but also splits the berries too. And this can be even more exacerbated with other grapes that have had damage to them, maybe by machinery and equipment, by the climate itself, hail, or by birds, for example, or animals. Okay, some of the most susceptible, by the way, are certainly tight bunches because it's easier for it to spread. It likes to nestle often in the central part of a bunch. It's not on that picture, but it's quite classic. I've gone through a lot of sorting before, certainly in the wet climate of the UK, and you often have to really get into a bunch if it's a tight cluster like Pinot Noir or Chardonnay, for example. Okay, let's talk a little bit about American hybrids. So, Vitis vinifera, which is our wine vines, lack the resistant genes, R genes, that would give you that natural resistance against things like rot and mildew. And of course, therefore, since time immemorial, certainly with the education behind us, we have really investigated the means to develop new vines which are going to have better resistance, reducing spraying, for example. So in some areas, certainly like eastern United States, like the state of Virginia, so if you think about north of Richmond, around Charlottesville, in the Monticello AVA, just off the Blue Ridge in Shenandoah, you'll find that those areas can get really warm and stormy in summer, and also can get very wet. There's often around 1,000 millimeters of rain falling in those areas. If that's the case, then we need to adapt. And in Virginia, they certainly have bred resistant hybrids that have always been a part of the landscape. And there's also a lot of active work breeding new varieties in research institutes there, as well as other key places as well. We know this because there have been repeated attempts to grow in places like Virginia since Sir Walter Raleigh named the whole of that eastern seaboard Virginia after his Virgin Queen. And they started to try and plant Vitis vinifera over many hundreds of years, 300-400 years, unsuccessfully. Whereas natural vines living there, the American vines, were thriving and surviving. Of course, phylloxera would be an issue, and that could be another factor that kill off the vines, but certainly many of them would have perished, the ones introduced from Europe to the Americas, due to things like mildew and rot. So the 19th century is some of the first deliberate attempts in the United States to breed new vines. There are reports from 1822 of Harvard researchers breeding hybrids between the European vines and the local indigenous vines. But things really kicked off in the middle of the century when breeders such as Thomas Volney Munson, Hermann Jaeger, and William W. Volk, and also Nicholas Herbemont, started sizable breeding experiments. And that's what gave birth to what we today call the American hybrids. So we know there's a lot of work today that have been continuing that, and we have almost like waves of lots of hybrids being produced. And one of the most recent waves in the latter part of the 20th century from institutions like Cornell, Minnesota, Michigan, Virginia would include grape varieties like Cayuga, which we find a lot up in New York State, Vignoles, Traminette, Marquette, and also the variants of Frontenac as well. The newer crosses that we're finding have more refined flavours. They still retain cold hardiness, certainly for these very sort of continental areas, and also disease resistance of the American vines. It's not all just happening in America. Later in that same century, there was also renewed interest in breeding not only disease-resistant varieties, but of course also phylloxera-resistant rootstock and vines. And that's when phylloxera swept through from the 1860s onwards. Now, all of the work in France, which was really a pandemic because it hit France the biggest, this phylloxera crisis, was on producing French hybrids. Now, the rootstocks bred back then are still being utilized today. The interesting growing hybrid direct producers, which we called HPDs, waned a little bit when we figured out that Vitis vinifera could be grafted onto American rootstocks. And of course, people went back to the more traditional ones just on American rootstocks. But there has been a recent burst in activity, and we are seeing, certainly focusing on American vines and even Asian varieties needed to produce crosses to confer significant resistance to the mildews, for example. Let's talk a little bit about ResDur. So this is where we're coming into talking about PIWIs, because this is the emergence really of our first big group of PIWIs. So in France, there was a long opposition to hybrids because of that negative connotation of the styles of wines they would produce. But even though they were disapproved, not all of the hybrids went away. In 1958, there were some 400,000 hectares of hybrids being grown in France, which is about a third of the viticultural area. By 2012, this number had significantly dropped. But hybrids were needed. They were, of course, desired for their resistance, but their yields. Remember, think about the 20th century, lots of political, social, economic strife, certainly centered around 2 world wars, lack of finance and income for many farmers, and of course, utilizing hybrids which were fungal resistant, which were productive and consistent, would certainly be a much more suitable outcome for many. And this is where we have things like Baco 22A, used for Armagnac, being bred, Chambourcin, Villard Noir, Villard Blanc, Planté, Sével Blanc, all being quite common. Now, there is an organization today called ResDur, Resistance Durable, so resistance durable, and this is a program of recent creation. Now, it actually started in the 1970s, but not under that name. This was when Alain Bouquet of the INRA Montpellier, so INRA Montpellier, identified genes from Muscadinia rotundifolia, which provided resistance to both downy and powdery mildew. And then he set about producing crosses with Vitis vinifera to make those new, what later we call PIWIs. He passed away, and his work was sadly at threat from being lost. But then that first gentleman you saw with the first holding slide, Alain Carbonneau, comes along, and he preserves that breeding program, relocating INRA, INRA, to Colmar in Alsace. So in 2000, the ResDur program was launched, and we have several now being added to the French catalogue, along with the PIWIs. The term PIWI could be applied to ResDur, by the way. So in June 2016, 4 varieties, that's Muscaris Blanc, Souvenir Gris, Monarch, and Priya, were included. And then there were many on a trial basis as well. And then also 3 more were approved if their name were to be changed, because of the confusion it may cause with the existing Vitis vinifera. So these were Cabernet Blanc, Cabernet Cortis, and Cabernet Jura. And in 2018, there were 4 more additions: Voltis, Floreal, Vidocq, and Artaban on the horizon. So today, let's have a little look here. Statistics are quite hard to come by for the volume of PIWIs in place. Some countries are not keeping consistent records of their existence. But in the PV International 2024 tasting competition, a wide range of almost 40 PV varieties were tasted, grown mainly in Germany, Czechia, Austria, but also Switzerland, France, and Italy. The most represented varieties are seen on the pie chart that's on your screen. So you'll see here Souvenir Gris, which I grow here in the UK, Solaris, Muscaris, but also others like Johanniter, Cabernet Blanc, Cabernet Cortis, Regent. So we've got quite a few there that I've mentioned already. So this gives you an idea. Now, these are just from that tasting, but it gives you an idea of the varieties that are certainly now being cultivated from PVs. So one thing I wanted to mention, I talked about this earlier, is in fact the breeding process. Now, I'm not going to go into a huge amount of detail, but I want to give you an insight on really how it happens. So here you'll see a picture of some vines in floraison, in flowering, and you've actually got some that have been bagged up here. This is the process that we use. So almost all cultivated vines are hermaphrodites, with both male and female organs on the same flower. The first step is before pollination, and this is to extract the anthers of each vine flower with tiny little tweezers that you would use for your nose hair, if you have it. And that takes out, the male component. And that leaves just the ovule and the pistil at that point. So it's at this point, it's the kind of mass that's in there that is being taken out by tweezers. Then this flower cluster is bagged to prevent any random fertilization, because of course you've got the wind and you've got birds and animals and so on. So that's what you see here. The flowers that we have emasculated, taking that male component out, is now bagged to stop any form of cross-pollination at this point. Now, the next step is to germinate the stigmatic fluid appearing in the stigma of the pistils. So that's basically the little tip of each flower. And that's from the pollen of the male parent of another flower. So this is for fertilization. So this will then be pollinated. And initially what they do is put that pollen inside that bag. They seal it up and they mix it around and they move it around. So the plant's flowers are, of course, becoming pollinated. Around 100 days later, you'll have a grape with mature seeds in it. You collect and sow those seeds, and these seedlings will grow into new grapevines. Each will be different, and many of them won't be any good. There may be very negative traits within how it grows and what it produces. So this is a long process for examining for positive features. And of course, we're looking for balancing of yield, resistance, for example, and also then organoleptic features, what it actually will end up smelling and tasting like. This, of course, is going to take a significant amount of time, many years. It will be 3 years, remember, until you get grapes, once you've planted those seedlings. So there's a long cycle here of taking cuttings from the most promising candidates and then going through further rounds of selection. It takes many, many years. So really, I think really from the first conception of this idea of doing flowering and then gaining lots of seeds from them and planting them to actually getting something that you can call a wine may take about 2 to 3 decades. Okay, so fairly significant time. But it can be sped up. The process can be sped up by a modern technique called marker-assisted selection, relying on known quantitative trait loci, QTLs. These are pretty much like genetic bookmarks, allowing you to see whether your crossing has the genes that you are actually looking for. So this will allow for optimization of the crossing combinations making identifying promising offspring much quicker. So you're basically bringing it forward by identifying by biology the key sort of characteristics of that vine. So marker-assisted selection speeds it up. And you can see whether or not there is desirable resistant genes in the present plant almost straight away, rather than letting it grow for seasons and putting it through test experiments. Also, scientists can find traits in wild vines, and then by a series of crossings and back crossings with the vinifera parentage, they can retain desirable characteristics from the wild vine. So that's very interesting because we can get a high genome content from the Vitis vinifera. And really for the future, the goal for breeding would be to identify markers for good fruit and wine composition, which would speed up the process dramatically. But at the moment, we can't define wine in molecular terms. So that's what's holding it up, but we are definitely moving with technology in a bit of a quicker way. So I thought I'd give you a bit of an insight there into the breeding program, how we do it. I will later, after this series, be introducing many videos of me interviewing key people within the breeding process to talk more in depth about those topics, to producing PIWIs for the global market. That brings me to a conclusion for the introduction of PIWIs. Please do join me for part 2, where I talk about some of the key white and pink PIWI grape varieties. This part, along with all other parts following, are only available to those of you who subscribe to my e-learning portal. That's over at www.winewithjimmy.com. If you do find yourself in the UK, then come and say hi for a glass, or bottle. I've been Jimmy Smith. Ciao for now. Goodbye.